Alright, what's up guys? In this video we're going to pick up some calculus here. We're going to evaluate another limit here. So we're asked to evaluate the limit as x goes to 0. We got the square root of x plus 2 minus the square root of 2, all divided by x. So the first thing you want to do with any limit is just plug in the value. So if we plug in 0, notice that we'll get 0 in the numerator, but that really isn't the issue. It's 0 in the denominator that is going to be the problem. And remember that division by 0 is undefined, so we can't have 0 in the denominator. But what we end up getting when we do a direct substitution is we end up getting what's called an indeterminate form. So in this case, the indeterminate form that we get is 0 over 0. There are 7 types of indeterminate forms. I have to remind my calc students all the time that an indeterminate form does not mean the limit does not exist. A lot of students get that confused and they assume that you can't do the limit or the limit does not exist just because you get one of these indeterminate forms. In this case, when we have something that looks like this, the more common indeterminate forms are going to be 0 over 0, infinity over infinity, or something like that. So what you have to do when you get these forms is you have to use a different technique to evaluate the limit. There's a variety of different things you can do depending on what you're given. You can do rationalization, you can factor, use trig identities when we're dealing with a trig limit, which we're obviously not here, but I'm just saying L'Hopital's rule does work well when you meet the conditions to use it. So there's a variety of things that you'll need to do. In this case, I'm going to go ahead and do some rationalization. So the great thing when you have limits that contain square roots is you can rationalize and you can multiply by the conjugate and see if that simplifies things out for you. So let's go ahead and do that. So let's write this as the limit as x goes to 0. And I'm going to take the square root of x plus 2 minus the square root of 2 and multiply it by the conjugate, which is the square root of x plus 2 plus the square root of 2. Now, if I multiply the numerator by the conjugate, we got to do the same thing for the denominator. So it's going to be x times the conjugate, which was the square root of x plus 2 plus the square root of 2. So this is how you have to write it out. Now simplify it. So it's going to be the limit as x goes to 0. And notice that I'll just end up getting x minus 2, or excuse me, plus 2 minus 2, all divided by x times the square root of x plus 2 plus the square root of 2. 2 minus 2 is obviously 0, so this just leaves us with the limit as x goes to 0. And what we'll have is x over x times the square root of x plus 2 plus the square root of 2. And hopefully you see here that the x's will effectively just cancel out. And so now what you'll have is the limit as x goes to 0. You have to write a 1 on top. And then what we'll have is the square root of x plus 2 plus the square root of 2. And now we got our limit. And now you try the direct substitution again and see what happens. So when we do the direct substitution, this is the limit as x goes to 0. You just plug the 0 in basically. And so what you'll have is 1 over the square root of 0 plus 2 plus the square root of 2. And when you take the limit here, you'll just get 1 over, I can write this as 2 times the square root of 2, which would be the limit. So that's your final answer. So your final answer we can say that L, which is our limit, it's going to be equal to 1 over 2 times the square root of 2. That's your answer. All right, so let me circle that for you, and that is how you evaluate this limit. All right, if you guys got any questions, let me know. I'll be more than happy to help you. All right, I'll see you guys next time. Y'all take care.